Is that mine? Perfect. Can everyone hear me okay? Perfect. Thank you, James. Welcome, everyone. Good morning. This is day 4 of the event, so I know that this is, we're almost at the end, and thank you for your attention. So today I wanted to talk about, what design freedoms mean in an additive manufacturing process, and for an approach like mass customization, which is like a high-value application for additive, what does that mean, and what are some of the opportunities that I think aren't being discussed or are being missed out on? I'm Ankush. I'm the entrepreneur of additive manufacturing at Glidewell. We are the world's largest dental lab, and we're based in Southern California. So to start off with, usually when people talk about design for manufacturing or design for additive manufacturing, there's usually two broad objectives. One is to kind of identify the limitations of your process and specific technologies that you've chosen, and the other is to kind of leverage the advantages and some of the unique characteristics that a certain production process might allow. And most conversations about design for additive, or DfAM as it's called, really focus on that first characteristic where it's talking about the limitations of additive, things like a specific build volume, having to navigate support structures, having to navigate just the basic chemistry of some of these machines. But I'd argue that most, we aren't really doing a good job of talking about that second column, which is leveraging the opportunities and what can additive really do. I mean, there are a few kind of key points that people often discuss with some of the things that only additive can do as a technology versus subtractive manufacturing, but it's really quite surface level, and I'm here to convince you that we haven't really unlocked most of that. So I mean, if we look at like just a standard production workflow for using additive manufacturing, if it isn't like high volume, then it's kind of fairly simple. It's pre-processing with everything that has to do with build prep and nesting, support structures. You actually go into the production step itself, which is the printing step, and then there's the post-processing. Again, some of this is technology dependent, some of this is application dependent. But I'd say I want to talk about mass customization, which we break it down in terms of defining it is really just the mass stands for high volume, and the customization means I'm just talking about a one-to-one mapping of parts to users, right? So I'm just talking about individual parts that are made for individual users, and I don't want to get into a semantic discussion about personalization versus customization or any of that. So when you do things at scale, the value chain looks a bit different from the way we see it. That first design step is really crucial because, I mean, there's of course a product development piece that happens before any of this is set up in place, but with mass customization, everything is custom. So there is a design step that is, that's just part of the flow of every single part that you produce. And that last step that is also different is a QC step. And again, this is just part of the process when you do anything at scale. You want to make sure that your process scales and your process actually delivers the right metrics that you're trying to achieve. So I want to take one kind of quick example. I've been told that looking at pictures of teeth on screen isn't the most pleasant thing. So let's go out of the dental world for a minute. Let's just take an example of like a mass customization application, like a custom bike grip, for example. So let's say that you have a custom bike grip that you're selling to users, and the whole process starts off with acquiring either a scan or a picture of your user's hand. So that's really that first step, which is the digitization and design. So you're just acquiring data from the consumer, and once you have that data, you're designing what that bike grip looks like. The next step, of course, with pre-processing is a lot of this gets fed into all the constraints that you put in product development. So, for example, most design for additive manufacturing conversations happen around the use of lattice structures. So let's say that these bike grips involve lattice structures, and they're optimized to kind of absorb impact and improve comfort and fit. So that bike grip is then going to run through that design pipeline that you have, and then depending on the choice of technology, you're going to have to pre-process that. So again, many of the kind of common talking points about design for additive really usually focuses on nesting or optimizing support structures or any of that. So let's say that we don't have any of that. Let's say we're manufacturing this using an SLS process, right? So no support structures, none of that. We're making a custom bike grip with an SLS process, and let's say for post-processing, we're going to depowder that. We're going to then run through like a vapor smoothing process, and maybe even like a coloring process, and then at the end of it, there's a QC step. So most kind of design for additive conversations really stop once that print button is clicked. Some of it has to do with maybe nesting and optimizing, making sure you can fit as many bike grips within your machine, making sure that the support structures are out of the question here because it's SLS. But yeah, so just identifying maybe certain specific features that are easier to achieve because you're using let's say you're using a TPU material, right? Like using an elastomer just because you want to make sure this is something for like a sports application. And my point is that first half, which is the entire left side, is kind of usually what we talk about. But once we hit that printing process, there's a few things that I think there's a lot more opportunity to kind of leverage design elements, and let's kind of go through some of that. So for the post-processing, the first step is going to be depowdering, which is getting rid of any of the powder from the actual build volume or the build cake. Let's try to think of solving that with a design solution. So what if we added channels that directed airflow and also dispersed airflow in a more effective way within those lattice structures, especially where the lattices get really dense and really kind of difficult for like a manual depowdering step. So let's add some of those channels in, and that helps with the depowdering step. The next is like a vapor smoothing step. So let's say you're vapor smoothing TPU, and there's a few vapor smoothing machines at the show here. For the most part, you're going to be hanging them on some kind of rack, and really if you have a solid bike grip, then you're going to have to drill a hole through that, or just figure out some way to get that into the machine. So what if we had like a small, tiny eyelet or like a fish hook placeholder at the end of the grip, and that allows you to actually, hang it within the vapor smoothing machine, but also based on how big your vapor smoothing process is and maybe some of the other parts that you're smoothing, you can actually decide how you want the part to be oriented within that smoothing process. So you can decide whether you want them stacked vertically, horizontally, what the spacing between some of these parts are. Some of this can also be based on just the performance of your smoothing machine, right? So it comes down to the interaction of the solvent with your TPU material. So we have that process we have the kind of eyelet or the fish hook that's been added. The next step is really, it's like a dyeing process, which again, everything we did for vapor smoothing applies, so I'm not going to touch that too much. And then let's talk about like a finishing step. This is the reason I'm separating out post-processing and finishing is because post-processing, again, is something as simple as depowdering or vapor smoothing, but the finishing is really going to be that final touch that you put before you can ship your product out. And there's very few processes that give you the kind of finish and the quality that you need right after it's been post-processed in an automated machine step. So that's just something that's part of the process, but doesn't necessarily have to be, kind of depends on your application. The last QC step, there's really a couple of different things that we care about. One is the actual QC step. So one is actually checking the quality, and how are we going to do that? The second is trying to ensure traceability, and how are we going about that? And then the third, which isn't really specific to that QC step, it's more, it's something that spans really 3 or 4 different steps, is part handling and part flow in general. So let's go through each of those. So firstly, with the QC step, again, we're talking about mass customization. So if you have high volumes, then ideally you want to move away from an entirely manual QC process. And if you're using any kind of optical scanning technology or some kind of mechanical testing, process to make sure that the part that you produce is actually up to spec. Then there's a fixture, or there's some kind of, whether that's the optical scanner or it's the actual testing machine, there's a fixture that's going to hold this part. And so that becomes, again, part of our design element, and we add grooves back to the part itself. So we have inner grooves that are going to interface with each of these machines and make the QC step not just easier and more effective, but actually semi-automated and standardize that to some extent. The next part of it in the QC is we care about traceability, right? Mass customization, we're doing things at high volume. We want to make sure we can track this and trace not just each part, but also be able to identify pass-fail based on our QC results and actually separate the process. So for traceability, there's a few different ways we could do that. We could either engrave or emboss like a part number or part ID. Doing that on the outside of this bike grip becomes a little problematic, especially if you have lattice structures. Doing it in the inside also not the easiest to read. But if we go back to the design feature we added for the post-processing in the vapor smoothing steps, we had like a fish hook that we added. You could add like a token or some kind of just like a tag with the part ID that attaches to that. And then as part of the final QC step, that's something that gets removed or machined off or cut off before. So again, it's just making the traceability easier, and that also makes it easier to read. So instead of just a part ID, if you have something like a data matrix or a QR code that's part of your production process, that becomes nearly semi-automated there, and it improves the streamlined ability of that process. And then the last piece of it really is kind of part flow. So between any of these steps, depending on what the part handling looks like, whether it's between like a vapor smoothing step and a QC step, or whether it's between just the printer and the depowdering step, being able to design elements of the bike grip based on the part flow is really important, but also it saves you a lot of time. So, for example, if you had a specific type of jig or fixture that was moving these parts from one machine to the other, then making sure that each of these parts can interface with that fixture and in a structured way, but also in a repeatable way, that automatically streamlines your process, but also reduces labor time. So that's really kind of the core takeaway from a lot of these design elements, is that we've added channels to improve the depowdering and make that more effective. We've added a couple of hooks and features to make sure that they're uniformly spaced out and we're getting optimum results from our vapor smoothing process. And we've also added grooves and inner mating components to make sure that we can actually interface with any of the fixtures and the QC processes that we have. And of course, we added the tag at the end that gives us the part ID for traceability. So, all of this not only streamlines process, but it actually reduces labor time. And I think all that feeds back into the business case for using additive for an application of mass customization like this. That's really where the process of additive, or as a technology choice, it's where that shines. Given the high complexity and high volume application. So going back to looking at things as a dental lab. So from our perspective, we have most of this introduced into our process, and we're working on introducing the other aspects of it. So I'd like to just maybe give you a couple of examples, and then I'll close out and let you guys enjoy the rest of the show. So for example, one of the other reasons that I separated out designing for post-processing and design for finishing is because design for post-processing, so most of our additive for the end part production is photopolymer technologies. So we're a dental lab, so one of the parts that we make a few thousands of every week is a night guard. So that's just something that you wear on your upper teeth. It prevents you from grinding your teeth, and also in rare cases it helps move your lower jaw forward so that it opens up your airway and helps you breathe better and sleep at night. So we make a few thousand of those every week, and for like a photopolymer process, that post-processing really is, unloading things off a machine, the IPA washes, curing step, and all of that's part of the post-processing. The finishing, however, because we're sending these to dentists, and every single part we make is unique, right? Essentially, these are batches of one, And so if we make a few thousand of these every week, we don't ever print the same guard twice. Unless we did something wrong, that's just not something that happens. So that means that there's a separate finishing or a polishing step that usually a skilled technician is going to do. They're going to have to eyeball things, and they've been trained over years and years. And there's actually design elements that we add for both of those separately that help improve that. So we're actually fine with increasing print time if it helps reduce finishing or post-processing time. And for example, with the polishing or the finishing, we'll sacrifice a quicker print to print these night guards at a specific orientation, just so that we have better surface finish on some of these features, and the technicians can kind of polish these a lot quicker. And for the post-processing and the traceability, for example, so we print out like a tag that again gets attached to the support structures, but also gets attached to the guard itself, and that becomes our kind of core piece of traceability that connects the actual physical part to whatever our digital design was. And once we've finished the IPA wash before the curing step, that's just something that gets snapped off and travels along with this part, and in separate fixtures, and then goes along the rest of the process where technicians will handle that. And at each step, that's being tracked. It's being matched up to that traceability token, and we know, in our design platform and our manufacturing platform, which particular design was meant for which case, and which dentist can expect a particular case. And then, in terms of, design for part flow, that really is, it's the same thing. So one of the other types of parts that we print a lot of are dental models, which are not the end part like a night guard, but it's just the base that's used as really an intermediate step to produce some other kinds of products. And the way we make those is we make sure that we design the base of those dental models to interface with certain trays and certain fixtures that help us move these parts along in an automated or semi-automated way through our factory, where it goes from process to process. And we standardize the part ID on each of those dental models so that it's always on a particular face, so that it's facing some kind of vision camera or like a data matrix camera, so we can track this at every step of the process, and we're tracking this throughout. So really, depending on the part being printed, there's a few different design aspects that can really help improve the printing process, the post-processing, and like a lot of the QC steps that I think aren't really part of the conversation for design for additive manufacturing. So I think my kind of last thing to mention is just that when it comes to design for additive manufacturing, there's a bigger conversation to be had about your entire production workflow, what that looks like, and then feeding back each of those steps and each of those design choices into the design of the part itself to either improve or reduce, improve the quality or reduce cost of the part. And especially when you print things at high volumes, this is where some of these economics really, it tips things over and makes additive the absolute right choice for this. Thank you.